Hello ladies and gentlemen, my name is Carl and in today's video we will continue on the 8/9 puzzle project. The goal in this video will be to create the basic movement logic and to create some of the scripts that will manage a lot of things in the video. For instance, the main script we will be working with is the game manager script, and we will start by coding that. Then we will continue with the cell piece scripts and adding all the logic for that. So first thing that we're going to do is a right click on your hierarchy, create new, and we're going to name this game manager. And when clicked on game manager, you're just going to go add components, game manager. And just for the sake of OCD, we are also going to reset the transform. And then we are going to double click on game manager. So in game manager, in game manager, the first thing we are going to do is make a singleton pattern. A singleton pattern is a way for us to get access to this specific script from anywhere in the game without having a reference to this specific instance. And the reason we can't just use a static class is because we need the behaviors within mono behavior, which is we can see is derived from here, or our game manager class derives from mono behavior, which gives us start, update, and one of the more important ones, awake. And we need access to these methods to set up a lot of logic. So a nice way to do that is with a singleton pattern. So right on top of here, I'm going to go hashtag region. And I'm just going to say, and right below that, hashtag end region. And within this region, we are going to create a public static game manager, and we're going to call it instance. And in our awake function, what we are going to do is instance equals to this. And you will see what that allows us to do later in this video. So for now, all I'm going to do is collapse those. Next, what I'm going to do is I'm going to set up my variables. So region. And once the region is set up, all I'm going to do is I'm going to create a header with tilemap, and then I will make a public variable, a public tilemap, and I'm just going to call that tilemap. And as you can see on top of here, it automatically added Unity Engine.tilemaps for me. A really cool function of Visual Studio. If you do not have tilemap or it throws an error, just make sure to include Unity Engine.tilmap. And the reason we need this is if we go to our game view, okay, let me just show you what I'm actually talking about. You see, this background object has a tilemap, and if we put that into Game Manager, that allows us to get every single position of these tiles. And why would we want that? Because technically, the cells or tiles themselves are in the grid. So once we move them, we want to make sure that they fit into the grid. And yes, we can hard code that. I just think it's a little better to have a bit of redundancy built into our code. And later on in this video, we will do that. So after this, I'm not going to continue with the game manager script. We are going to continue with the cell piece script. So right at the bottom here, I'm going to say on mouse down. Now, what this method does is every time this object is clicked, it will do something. So another way we can test that is say debug dot log. There's only one trick with this. If we start the game, we will see even though we click on things, nothing happens. That is because the cell pieces themselves do not have a collider. So even though you click on top of them, the game doesn't know there is something you want to click on. And you'll see what I mean now. First, we will need a box collider. Box collider 2D. And if we go into scene view, while we added it to our cell piece 0, press F. And with this selected, we can see with the green line that it is the same size as our tile. And that works perfectly for us. So now, if we Control S to save and play the game again, if we click on 0, we will see here in our console that yes, it is clicked. So what I'm going to do now is I'm going to select all my cell pieces by holding Control and add component, box collider 2D. So if I play the game and keep an eye on my console, I press on 7, 6, I press on all of them, it registers in the console. And so, just to test something else, I'm going to change this message to cell plus, and right on top here we have cell value dot to string plus, and all I'm going to do is add a bit of formatting there. I'll tab back to our game, play, and we should see cell 0 clicked and cell 7 clicked, and that should work fine for all our cells. And this allows us to do a couple of things. For instance, now from we only have to do all our logic within one script. So under here in cell piece, I'm going to add another region, and I'm just going to call this logic. And within this, I'm going to create a few methods. So the first method is going to be void move cell. This is what we are going to call if we want to move a cell. And all the logic will be in here. In the logic, a couple of things must happen. We must see if we can move. We must get the move direction. And after we got the direction, we need to perform the move. So all of this can be broken into different methods to keep it nice and clean. So the first method that we will do is a bool can move. What this will do is it will tell us if this cell can move. What we will pass into it as a parameter is a class called vector3int, and I'm just going to call this underscore cell. And just for now, to get rid of that pesky red line, I'm just going to say return true. And now we're going to do some math. Yay! The most exciting, boring thing on the planet. One of the things we need to do is we need to get access to the tile map. We are going to do this in awake. The wonderful awake method. And because in Game Manager we already have tile map set, we do not need to worry about when tile map gets instantiated. So in here, in our cell piece, we can just copy and paste the code for public tile map. And over here, right on top, we can and turn that to private. Little life tip here, when you get something like this, just click on it and hit Control and period, and it will bring up this menu here, and you can see it says here using Unity Engine.tilemaps. If you are not sure about what you need to use or stuff like that, just use this function and maybe it will help you, maybe not. And it added for me unitengine.hammer. So, and because I'm going to make this private, I'm just going to add another region to keep things nice and neat. And I'm just going to Control X and Control V. So, the reason we need this is for the following steps. Over here in can move, we need to check if our current position plus this cell or whatever can move. So the first thing we need to do is get the specific tile. So we make a variable tile. It didn't add anything above because tile is part of a tile map namespace. Just call it tile equals to tile map dot get tile. Just pass in tile as the type, and then cell. So basically what this method does is we want to check if there is a cell or a game object in that in the space we are trying to move to. So if I open Excel, currently let's say this is our 0, 0, 0, 0, 0. This is our 1, 0, 0, and this will be our 2, 0, 0, 0. If we start here, we want to see if this tile here or this position here has a tile or a game object. If it has neither, we can move there. For instance, let's say over here we will represent our empty space by a -1. This 0, 0, 0 will be the upper left tile in our game. Essentially, at the start of the game, this will be our number 0. So on the top, there will be a tile. On the left, there will be a tile. On the right, there will be a game object. And to the bottom, there will be an empty space. Now, the reason we're doing it like this is because of the logic of the game. If you are not familiar with the logic of the 8-puzzle game, I'm just going to bring up my previous project. When we play this, you will see the following. At any moment of time, there is only one possible move. For instance, 7 can only move right. 5 can only move down. So when we click on a tile or a cell, that specific cell can only move to a single position. But if we click on 0, for instance, it cannot move in any of these directions because it is there's no possible moves for it to make. So I think I changed the coding of this specific cell. Let me just check cell 1. Yes, I disabled the box collider. So as you can see, logic dictates that at a time a single cell can only move in one direction, but at most there are 4 possible moves. Once we get into the search algorithm to solve this puzzle, you will see that that creates a problem or a optimization problem for us later. But for now, because we're doing all our logic within the cell itself, there's only one possible direction to move in, so that is completely fine.